Welcome to another podcast. In this episode, we're going to be taking a look at how to find the normal line to a curve. And before we get too far into that discussion, what I'd like to do is just sort of recount what we know about tangent lines, because it turns out that finding the normal line to a curve depends on tangent lines. So if you think back this semester, we've talked about the derivative for a while now. And we identified the derivative as being the slope of the curve f of x, which is nice enough, but really we were more interested about geometrically what goes on at a single point. And so if I evaluate the derivative at the point A, then yeah, I think of this as being the slope of the curve f of x at the point x equal to a, but the better geometric interpretation of this is that it's the slope of the tangent line at x equal to a. So if you think about lines, so if you take the line y equals mx plus b, and you tell me that you want to find a line that's perpendicular to it, then this line has slope m, and whatever line you come up with that's perpendicular to it will have slope that is the negative reciprocal. So this will have slope negative 1 over m if it's going to be perpendicular. Now it'll have a different y-intercept, and I'm not going to calculate what that y-intercept will be. We'll just call it c here. But these two lines would be perpendicular to each other. So the idea is that if we want to find a line perpendicular to another line, we just take the negative reciprocal of its slope. And that's a good thing, because in this scenario, what I'm basically talking about here is, suppose that this is the tangent line over here. So we know the formula for the tangent line has slope f prime of a, and then it's x minus a plus f of a. So suppose our line is the tangent line with slope f prime of a. And what if I wanted to find the line perpendicular to it at the point A? Then that line that's perpendicular to it will have negative reciprocal slope. So instead of being f prime of a, it'll be negative 1 over f prime of a times x minus a plus f of a. And so this is called the normal line to the curve f of x at the point x equal to a, and you can see that it has slope that is the negative reciprocal of f prime of a. So as an example about this, let's calculate the tangent line and normal line. So I want to calculate the tangent and normal lines to the curve. Let's do f of x equals, so we're going to keep it pretty simple. We're going to look at a polynomial here. At the point x equal to 5. So we already know how to find the tangent line, and thank goodness we don't have to use the definition of the derivative anymore. We can use the operational properties of the derivative, in particular power rule there, because we're dealing with a polynomial. So I know I need to find f prime at 5. So I'm going to start by finding the derivative. The derivative of the function is 3x squared minus 18x plus 5. If you need to, go back and review the power rule formula, but that's what I'm doing there. It's just power rule. And thinking about the pieces we need, if I come back over here and look at my two formulas, I'm going to need to form the tangent line, and I'm going to need to form the normal line. So I need to know f prime at 5. Well, that's just going to be 5 squared minus 5 plus 5. So f prime at 5, that turns out to be negative 10. Go ahead and double check that in your calculator if you'd like to. I also need to know f at 5. I need to know the function at 5. So the function at 5 is 5 cubed minus 9 times 5 squared plus 5 times 5 plus 4. And that turns out to be negative 71. And then the final piece I'll need to know is the slope of the the slope of the normal line, which is negative 1 over f prime of 5. Since f prime of 5 is negative 10, this is negative 1 over negative 10, or positive 1/10. So I have everything I need here. The tangent line to this curve is going to be y equals f prime of 5, which is negative 10, x minus 5, plus f of 5, and f of 5 is negative 71. So just cleaning this up a little bit, this will be negative 10x plus 50 minus 71, or negative 10x minus 21. So there is my tangent line at the point 5. The normal line, which is the line that is perpendicular to the tangent line at this point, has a slope of 1/10 instead of negative 10, but everything else about forming the line's the same, so plus negative 71. Distributing the 1/10. And then finally, writing it in the form we're used to, mx plus b form. Getting a common denominator there. We end up with the line 110x minus, if you want to think of this as 71.5 you can, but 7/15. And so that is our normal line solution. Now, it's one thing to calculate them, it's another thing to understand kind of graphically what they look at. So what I've done is, in Maple, I've graphed both of these lines, and you can see here that the curve in green is the polynomial that we looked at, and then the tangent line is the line in red. You can see it follows the slope of the curve, and the blue line is supposed to be the normal curve. Now, remember I got through saying that the normal line is supposed to be perpendicular. Perpendicular lines meet at right angles, and it's clear that that does not look like a right angle. What you have to keep in mind is that when things are graphed on a calculator or in something like Maple, they try to give you a window that shows you a lot of things, but they don't always make that window square. In other words, there's a lot bigger range on the y-axis here than there is on the x-axis. So it's not a square look at actually what's happening at that point. If I wanted to look at it more square, then if I was on a TI calculator, I might do something called zoom square. Here, what I can do is I can zoom in on the interesting part. So I'm going to zoom in a little bit in here. So I'm cutting down the difference between my scales here is basically what I'm doing. And it still doesn't look perpendicular, but what I can do in Maple is run a new command called scaling equals constrained. And what that essentially does is it makes everything sort of squared up. Obviously, that's why Maple doesn't graph it for us like that, because you can see what happens. The y-axis is so much bigger than the x-axis here in terms of values that it squinches everything and you can hardly see it. But once again, if I zoom in on things, it starts to come into focus a little bit more here. Zoom on things down here. Zoom in a little bit more. And here's finally a pretty decent picture. You can see the tangent line in red following the curve in green, and you can see the line in blue cutting across it, and you do indeed see that the red line and the blue line meet at a right angle. So the normal line and tangent line are indeed perpendicular. Just keep in mind that if you don't have the scaling right on your axes, if it's not a one-to-one scaling, then it's not going to look like it's perpendicular. So just keep that in mind. But you are indeed finding a set of perpendicular lines that cross through the point at 5, one being the tangent, the other being the normal curve. Alright, thank you for watching.